We're told that Kayla rode her bike 75 miles home from college one weekend and then rode with a bus back to college. We're told it took her 2 hours less to ride back to college on the bus than it took her to ride home on her bike, and that the average speed of the bus was 10 miles per hour faster than Kayla's biking speed. And we're told to find Kayla's biking speed. We'll call Kayla's biking speed R. So we're looking at distance equals rate times time. So again, we'll set up our little chart. We'll call this home and back. And we're looking at rate times time equals distance. So our rate, we said we would define her biking speed as R. So this is bike, and this is bus. So her rate is going to be R for biking, and then the trip back to college on the bus, we're told it's 10 miles per hour faster, so it would be R plus 10. Now, in both instances, the trip was 75 miles, so we fill that into our chart as well. Now, how do we find our time? Well, if distance equals rate times time, then time equals distance divided by rate. So this would be 75 over R and 75 over R plus 10. Now, how do we put this all together? We're also told it took her 2 hours less to ride back to college on the bus, which is this 75 over R plus 10. So we're going to have that her time biking, so 75 over R, equals her time on the bus. We could do this a couple ways. I'm going to go ahead and write it with it on the left-hand side. 2 hours less to ride back to college on the bus than it took. Well, that's 2 hours more. So 75 over R, which is her speed on the bike. So the time on the bike. So the time on the bike minus 2 hours is going to equal the time it took on the bus. So 75 over R plus 10. And now we have our rational equation. And we can multiply both sides by the least common denominator, which is R times R plus 10. So on the left-hand side, when we distribute to the first term, the R's cancel. We're left with 75 times R plus 10. Distribute to the second term, nothing cancels, so we have 2R times R plus 10. On the right-hand side, we only have one term. The R plus 10 cancels, and we're left with 75R. Now we distribute on the left and then combine like terms, so 75R plus 750 minus 2R squared minus, don't forget to distribute that negative both times, minus 20R equals 75R. So if we move everything to the right-hand side, we add 2R squared to both sides. We have 2R squared. Then 75 minus 20, that's 55R. So we still have the 75R. We're subtracting 55R. And then subtract the 750. So we have minus 750 equals 0. That gives us 2R squared plus 20R minus 750 equals 0. Everything is divisible by 2, so we have R squared plus 10R minus 375 equals 0. So now we want to look at, since we have a leading coefficient of 1, what numbers multiply to negative 375 and add to 10. So after some trial and error, we would figure out that the two numbers that multiply to negative 375 and add to 10 would be 25 and negative 15. So if we factor, this is just going to be r minus 15 times r plus 25. That equals 0. So r equals 15, or r equals negative 25. So right now it'd be impossible to have a negative rate when we're looking at the r stands for the rate of her going home on her bike. So we'll get rid of the r equals negative 25, and that's going to give us r equals 15 miles per hour. And since it's 10 miles per hour faster with her riding the bus, it would make sense that r equals negative 25. That's the speed of the bus going in the opposite direction. So we can just say that Kayla's biking speed was 15 miles per hour.